the agenda today.
Yeah, hold on a second. Can you guys see my screen?
Yes.
Okay.
We are looking at the outlook. Is that
There's OneNote.
There it is.
yeah? Okay, here it is. Hi everyone. Welcome to this monthly TSC meeting. As usual, this meeting will be recorded, so be careful what you say. Let's take in everything in a respectful manner. For the agenda today, we have 2 items. The first item is the project proposal from Deepak. Actually, this is an item that we postponed from last meeting. Because in last month's meeting, we spent too much time on discussing the scalability 6 work. So we didn't get enough time to this topic. That's why we moved this to this meeting. Deepak, do you need any like TSC vote on for this item?
Well, let me present it, and then we can, yeah.
Okay. Yeah. After that, we have Peng Du, who is leading our EdgeSeek. He will present the high-level architecture and the plan for the EdgeSeek in the next for the work in the next few months. And he hoped to get some feedbacks and some advices from TSC members. These are the two items today. Let's start with Deepak one.
Okay, can I share my screen? Okay. Can you guys see the screen? See.
Yeah, Deepak.
Yes, we can see it.
Okay, good. Okay, so I think this is a meeting before the previous meeting. I think we discussed, and I mentioned that, about the whole scalability in a Kubernetes environment. So Apache Ignite as a Kubernetes API server data store. So I'm gonna cover, what the issues are, and what kind of work we did, and how did we kind of enable the scalable Kubernetes environment. Oh, what's going on? Okay. Guys, see that problem slide?
Yes.
Yeah, you see. Okay, good. Okay, so I think the key, I think most of you folks are familiar with Kubernetes. So Kubernetes server, in Kubernetes, the API server is the heart and soul of any Kubernetes cluster, actually. It's equivalent to like a syscall of a Linux kernel. So it's a very important, so essentially the way it works is just kind of a high level, 30,000 feet level description. API server in Kubernetes has long pretty much relied all this time has relied on etcd as the underlying schematized key value store, and when the controllers operate on it, in order to achieve the current state to desired state. So all this time, it's been etcd has been used as a data store, as an underlying data store for API server. Now, because of the non-partition nature of etcd, it places a lot of limits on how much vertically it can scale. So essentially, the currently the etcd, it doesn't scale horizontally, so you can only scale it vertically. Okay, and then So you can have multiple instances of etcd, but they are for high availability. See, it's only one at one time you have one master active basically. So what that does is makes etcd highly available but not scalable. See, you cannot horizontally scale it. And the limit of how much you can scale etcd is essentially it freezes, after some time, in recent experiments, in the community. So they have gone up to 10,000 nodes actually, and then after that, pretty much etcd freezes. So you cannot go, your cluster cannot go beyond 10,000 or 15,000 nodes in a cluster. Okay. So this overall, this non-partition nature of etcd contributes to the lack of Kubernetes cluster scalability and overall kind of efficiency in a hyperscale Kubernetes cluster environment. So if you want to have a bigger cluster, with 50,000 or 100,000 nodes, you can't do that with the current etcd as a data store. So what we did was, we kind of started exploring, what if we have a true partition underlying distributed data store as an alternative to etcd, and on top of that, and that data store is in memory. So see if that will allow scalability of a Kubernetes cluster. And to that regard, we did a couple of months ago actually, we finished our collaboration with the GridGain folks actually to see if we can replace the Apache Ignite open source in-memory partition data store to replace etcd in Kubernetes and see how how it helps scalability in a Kubernetes cluster environment. So that's the work we did, and then this is kind of a high level. So you can see that there are three pictures on the screen. So what we did was, in order to demonstrate the horizontal scalability of Ignite data store. So the very first screen, the screenshot you see here is we did experiment in Google Cloud. Essentially, we ran Kubernetes cluster by limiting the using etcd and using by limiting the CPU and the memory configuration as 4 gig of memory and then 400 milli CPU. And then this is essentially running on E2 high mem 2 machine type in Google. So by restricting this limit on the cluster, so etcd chokes basically. So when we ran a density test with this memory and the CPU configuration, etcd chokes. So that's what we wanted to demonstrate, to find a threshold where etcd chokes, and there's nothing you can do about it basically. So let's say you have, hello, yeah.
How many nodes in this test? I mean, how much capacity is on the Kubernetes side, API server side for this test?
Oh, this was running on an E2 high mem 2 machine basically. This whole cluster was running on this machine.
Yeah, no. I mean, when the etcd times out.
So you see that 4 gig of memory and then 400 milli CPU. That's the
etcd configuration. I mean, on Kubernetes side, let's say when you run the test, how much node did you put on the cluster?
How many nodes?
Yeah.
The nodes were
like how many nodes, how many ports?
Hollow nodes. I don't recall that. I don't know how many.
That's fine.
Yeah, I don't have that. But yeah, so I think they were not. I think maybe 500, but not even less than that, because we couldn't even. Yeah, even less than that actually.
I see.
So we didn't really try to scale it. We wanted to the core, and I'll get into that why we didn't try to do that kind of a scalability testing. So, but the key goal was initially to kind of demonstrate the limitation of etcd. So basically, so you can see that by having this this configuration, etcd chokes, and there's nothing you can do about it at that point. The whole cluster kind of times out. So every API server starts timing out basically with this. And then what we did was in the screenshot in the middle. So we replaced etcd with Ignite with the same memory and the CPU configuration basically, and then that chokes as well basically with the one node of etcd Ignite cluster. Okay, and then what we did was, so because as opposed to etcd, Ignite is horizontally scalable. So you can see that on the green the screenshot. So we started horizontally scaling the Ignite. So we added 3 nodes, for example, in this case. And then everything kind of went fine. So there was no problem. The Kubernetes cluster density test, successfully completed. So you can see that the key thing to highlight here is that there's a limit to how far you can go as far as scaling vertically the etcd. And at that point, there's nothing you can do about it, basically. But as opposed to if it's a true partition data store underneath, like Ignite, that essentially addresses that issue. So we were able to successfully demonstrate that you can horizontally scale the underlying data store and keep going.
Yeah. In the last case, the 3 Ignite instances, they are partitioned, right?
Partition, yes.
Okay,
yes.
good.
Yes. Yeah. I mean, that's like inherent. You just keep on adding nodes. You see, and it partitioning automatically, the Ignite will take care of it.
For each partition, is each partition also highly available?
Yes. Okay. So each one of them, they have the master slave configuration.
Okay, good.
Yes, they do. Yeah. So they have redundancy at every level, actually. Yeah. That's true. Now the thing is so one of the things which we didn't do it was to now we know that the Ignite is can be horizontally scalable, but we didn't really go to the extent of doing high scale, the testing with the bigger cluster with 20,000 or 30,000 nodes in it. You see, and one of the reasons we didn't do that was we had some budget resource constraint issues as well, and at the same time we found out that at some point, even if your data store is partitioned and it scales horizontally, but the API server itself chokes basically. The Kubernetes API server has its built-in cache in memory, so that starts choking. So that doesn't really help. You see, so we decided that even if we spend time and spend kind of money to kind of do that level of testing, we're not going to go beyond certain limit. You see, so essentially, it's not just a matter of scaling your data store, but there needs to be some work done at the API server level in Kubernetes as well. So that's when we decided, let's not do this the high scalability testing at this time, and we will do that as part of Centaurus, where we have addressed that issue by partitioning the API server itself, actually. So, and that's what our project proposal is, actually. You see, so we plan to do by replacing etcd with Ignite, and at the same time be able to leverage the partitioned API server capability as part of Centaurus, and then kind of demonstrate and then see how high we can go. And we're pretty optimistic that we can easily go like 50,000 or whatever nodes actually by partitioning the API server, and then the data store is automatically partitioned anyway. So yeah, so that's where we stopped. So we did, just to kind of summarize that, we as part of the collaboration, we demonstrated the horizontal scalability, but we didn't really do large scale testing because of the reasons I mentioned, basically. Yeah. And this is a high-level architecture, just like any partition data store type. I think Dynamo, Amazon Dynamo, I think, but that's not in memory, but any partition database works the same way, actually. So what we did was we built, the way we did this whole replaced Ignite with etcd with Ignite was, essentially, Kubernetes doesn't even know, API server doesn't even know. API server still talks the etcd APIs, and we put together, we built a shim layer called Ignite etcd shim layer that does conversion from etcd API to the Ignite API underneath it, basically. So from a Kubernetes or API server standpoint, he's still thinking that they're talking to etcd data store, but the shim layer overrides that and then uses the underlying partition Ignite data store, basically. And so the Apache Ignite is horizontally scalable, so that solves all the issues of vertical scaling. Remember the thing I mentioned at some point, vertical scaling is just that the whole cluster chokes. So that by horizontally scaling it, you kind of address that issue. And then this is everything kind of goes through the API server traffic. All the calls to the underlying data store goes through Ignite client, which is the proxy, basically. So the proxy is aware of all the partitions and all that. And depending on your partitioning logic, it will route that API call to the appropriate partition, basically. And this is all redundant. And so this proxy, you can have multiple copies of that, basically. So, and this is what we did. Essentially, what we did was, as part of our collaboration till now, we have achieved functional parity with the Kubernetes. So essentially, we enhanced. So the current, when we started this collaboration, the Ignite data store did not support a lot of features which etcd supports as part of Kubernetes underlying data store. So we had to kind of build all those, plug all those holes. And this is all all of the functionality we had to kind of build out in order to be, in order to replace etcd as a data store. So this is, so what we have done is, so we have, in the previous slide, I demonstrated that Ignite scales horizontally. So we demonstrated that, and then we demonstrated by running the 3 different tests we ran. We ran a density test, which is part of the Kubernetes, and the load test, and the integration test. So by doing, and then they all passed, basically. So what that means is, so we have a functional parity with the etcd. Okay. And then these are the security features, actually. Yeah.
I'm sorry, one question to the previous slide. Is this now part of the Ignite, or is this did you fork Ignite?
Yeah. So this is this is currently on it. This is on this repo right now. All the work we did extending Ignite is not upstream to Ignite yet. So this is currently sitting on this GitHub. All the extensions to Ignite. And by the way, we didn't touch Kubernetes at all. All the extensions, all the functionality which we built was by extending the Ignite data store, and it's sitting on this GitHub. And the plan is, and the proposal, the reason I'm presenting this thing today is to incorporate this work as part of Centaurus, and then at the same time demonstrate the scalability of Centaurus beyond 20,000, 30,000 nodes. That answer your question?
Great, thank you. Yes,
Nice.
Okay, good. So this is, I'm going to quickly, so these are the security inherent security capabilities within Ignite, so we can tap into the, once you replace etcd, you can encrypt the data itself. And then we had to kind of build all these metrics and all that in order to be fully compatible with the etcd functionality in Kubernetes. And so, yeah, so currently, as I mentioned, this is where all the code sits. So actually, anybody can go in there and then play around with it. But the goal is to incorporate the proposal in this, as part of Centaurus, proposal is to include this work as part of Centaurus and then demonstrate the high scalability of Centaurus cloud platform.
So Deepak, do you propose to move this repo to the Centaurus org?
Yes, that's the plan. So once we successfully integrate with Centaurus, so currently it's integrated with Kubernetes. So obviously it should run seamlessly, as part of Arctos or Centaurus as well. So once we do that and successfully demonstrate all that, the plan, the proposal is to move all this as part of Centaurus itself. So it'll be like a project, just like in Kubernetes, there are different projects. So this will be like a one project underneath Centaurus. That's the proposal.
Do we want it to be a standalone project, side by side with Arctos or a part of Arctos? I mean, well, it's definitely a standalone repo. Do we want to make it a standalone project as well?
Well, so I think so. So currently in Arctos, we already have the partitioned etcd functionality basically.
Yes,
so we
exactly.
need to kind of think through it. Either do we kind of replace all that and then use Ignite as the underlying? So I don't know. We need to see basically. So or should we have Ignite data store as an option as a project? Basically. So we need to decide one way or the other. So we can either replace. So just to let the other folks know, Stefan and Prashant and everybody else, that currently in Arctos we have done some work as far as partitioning the etcd, but which is kind of not really a true partitioning. But we did that and it works, and we are able to get pretty good numbers actually. So one way would be to kind of not just replace the work which we've done in Ignite and replace that on top of the work we have done, or have Ignite data store as an option basically. So you can, as part of Centaurus, you can choose one or the other basically. So we need to decide. So I'm not really sure what we want to do. So we can have that discussion. But in either case, we will move this code either as a alternative data store in Arctos or Centaurus, or maybe just replace the partition etcd work which we have done basically.
Yeah, I think the first step we can move this repo as a new repo under the Centaurus org, right? So
yeah, exactly.
The standalone repo. And
let's make it a project, and then we eventually will see.
Then eventually we'll see how it can be.
That's exactly that should be the strategy. Yes.
Yeah. To accept a new project or new repo actually requires the TSC to vote. Today we have Deepak, Stefan, and Prashant and me on join this meeting. We already reached a quorum. So Moni, can you have launch a vote on this? Basically asking if TSC members are okay with accepting this Ignite repo into Centaurus.
Deepak, one quick question for you for the
Sure.
etcd versus the Ignite thingy. What are the upstreaming effort? I mean, when you guys did that, did the value, I mean, I can see that it does a horizontal scaling, but the value add, was it like really beyond, above and beyond when you noticed it? And
why did we decide to do that?
Did you give the feedback to the Kubernetes community?
Oh yeah. So yes, we did. So we were in touch with the API machinery group. So they're very happy to see any data store. I think AWS guys did the same thing actually. They tried replacing. I don't know what I don't think they have published that information. But there was a discussion. They replaced etcd with Dynamo actually. Yes.
Oh, okay. Yeah, that's the service that already online. That's already online. They build.
Yeah, but I don't think it's open source though. I think they've done.
No, it's not open source.
Yeah. So they did that. So Dynamo guys did that, and it's part of AWS. They were just like AWS. Everything is commercial.
That's got it.
And then there was another work, part of K3S actually. You see the K3S. You know the smaller version of Kubernetes. So they replaced etcd with it's a project called KINE, they replaced it with the stripped down version of etcd and using a SQL server, a SQL, MySQL actually database underneath it as a data store. But that's part of the K3S project itself. Now, so one of them, there are two efforts done, just like what we did. One effort is part of AWS, which is not open source, but the kind is part of K3S and it's part of CNCF. So, and most likely we're gonna reach out to CNCF as well, see if the Kubernetes community can benefit a lot from this effort, which what we did as well. So just like Centaurus. So potentially this could be a CNCF project, itself. You see, now there's a difference with the work that the K3S guys did was the effort they did was part of the K3S itself. But in our case, it will be a standalone project, a data store replacement. So we need to kind of explore that. We haven't done that yet, but that will be part of CNCF.
Got it. So effort mainly involved into our area would be replacing the etcd with the current Ignite module, right?
Exactly. Yeah. And then so Kubernetes community, we've been kind of working with them as well, and they suggested that we should make it a project as part of CNCF as opposed to in Kubernetes itself, just like other people have done that.
Yeah, normally I have seen like sometimes the communities are in the research mode, and if already they have planned, we need to be also like evaluating that portion, that how far they have been with some of this capability. I mean, it's always good to have like building our own and merging it back with their system, but let's see. I mean, I support this because it shows a lot of value in terms of scaling the system. So.
Done?
Okay, yeah, TSC members, please vote on the options that Zoom Moni sent out.
Yeah, probably have everybody.
Okay, great. We with the 40th member here, we reached the quorum and we approved this etcd Ignite project to be a new sub project of Centaurus project. We will publish it in the part of the meeting notes. And Deepak, who will move this repo to the Centaurus?
Well, yeah, so we will have to work it out. I'll work with you on that. I think we need to have, so one of the effort which we're gonna do to do the scalability testing. So we would need to involve GridGain folks as well. So I was hoping that Nikita is in the call and they'll be very happy to kind of participate in that because it's in their interest as well. Basically, see, they can go and tell the world that, we can be the underlying data store for cloud environment.
Yeah, yes. I'm also a little surprised to see that Nikita is not here today.
Yeah. I think so. He's traveling. So yeah. So I think that they showed a lot of interest. It's in their interest as well because they want to do a lot of marketing stuff and all that. Based on the results. Once we demonstrate that we can scale up to higher number of nodes in a cluster. Okay, great. Yeah, I will follow up with you offline to see how we move the repo and all the related issue of PR history. Okay. Thank you, Deepak, and thank you, Moni, for sending out the survey. And next we have the second. Remember we mentioned in last TSC meeting we will have a rotated SIG review. So far we have 4 SIGs. Last time we reviewed the work and the planning from the scalability SIG. This time, Pengdu will present the plan and high-level architecture for the edge SIG. Peng, it's your time.
Thank you. So yeah, for this part is a high-level review of our thinking and design for the edge. The goal is to extend the Centaurus functionality and the infrastructure to be able to support workload on the edge. And we'll talk about that and what that means. Currently, we put a code name under this. It's called Fornex. If you wonder what that means, it's a constellation. The mental image that we can have is think of Centaurus or the Arctos as a cluster of stars, and the edge feature would be another cluster or another few clusters of stars surrounding Arctos. Okay. So this is the agenda today. We have 4 parts. We talk about the use case, requirement. The requirement is based on what we see and what we think is necessary for and practical for Arctos to support. Based on the requirements, we will talk about the how we think the edge feature for Arctos should look like, all the modeling and design, and also the proof of concept is ongoing. And we'll report some of the progress. And the goal of the talk today is to introduce this project and to get feedback from you guys. Okay. So let's talk about the use case first. So far, based on what we have, based on the research we have done, there are 3 kinds of use cases for edge. One is IoT. That's essentially you have some device, so you have Alexa at your home and you want to control that, you want to do some inference on the edge in your house, and you want to do some data mining or some AI stuff in the cloud. That's the kind of IoT edge. So second kind is we call that smart factory. Think of that as you have a factory, you have a small restaurant, and that in that we have some kind of cluster running workload in there. So it's not a single node, it's a set of nodes running together. And the third kind is 5G and MEC. The kind of scenario is the user can be moving fast from a certain location to another location. So the user session and all those user data need to be accommodated based on this. That's the difference between the third one and the first 2, because the first 2, the connection point usually does not change. And the third one, we are assuming that the user can be moving around, right? So we have 3 kind of, we have seen that there's 3 kind of use cases for edge. So the first kind, just to show you some solutions from other source. One is you can think of this as essentially we have some heavy loading running workload in the cloud, and we have some devices running on the edge. These are the 2 2 examples. One is from Azure, the other is from Google. The idea is we can run AI, we can train the model with a lot of data, from everywhere in the cloud, and we can run the inference. We can send the model to the edge, and we can run the inference on the edge, right? So this is the IoT edge. The other kind is, as we said, you can have a small cluster running. This is an example from Chick-fil-A, where they have so many restaurants. All you see here is the restaurant they have across the United States. And inside each restaurant, they run this cluster, right? And then the problem comes, do we treat them as a cluster of clusters, a set of clusters? Then how do you do deployment? How do you do maintenance, all kind of things? So this is another kind of edge. So the bottom line is when we talk about the edge, it's not just a device, it's not just a camera somewhere, and we're controlling that in the cloud. It could be a full-fledged cluster on the edge. Okay, there's some other use cases. I will not spend too much time into it. Here, I'm just showing some picture or some of the infrastructure design that they have, right? This is from one of the Aquino project. This is from a Starting X. And I'm gonna show a few of them, but you don't have to you don't have to look into the details too much. The idea here is based on this picture, we can see that for edge design or for the next generation edge design, there's a common thing between all these different pictures or different projects. The common thing is essentially what our key requirements come from. So here you can see that it's not just one single level. It has a few levels. The same story here. We have on the right, we have it's called the regional data center. We have local data center, edge, and all these things. So it's not just one cloud, one edge. It has something in between them. Okay, so we took that as one of the projected infrastructure for the future, and we want to say, okay, how do we accommodate this? What kind of feature our Centaurus edge should support? We come up with two things. One is we think the edge should be autonomous. So the idea is that there are two things that could go wrong, essentially, or at least two things that could go wrong. One is the network, because edge, we cannot assume edge has a very stable connection. It's not like in those CNCF projects where everything is in the data center is well maintained. It has the staff working on it. We cannot assume that the network could come and go. And the second one is the edge node. So if you have a node that's running in the restaurant, that's running in the desert, that's running in a car, there could be no staff working on it, and that node could go down, right? So we have these two situations, and we still want to be able to support the workload. The idea is for Centaurus edge, we want to be able to support the case where if 1 and 2, if condition 1, condition 2 happens, we want the workload to be still running as much as possible. And also, when 1 and 2 happen at the same time, we still want to be able to support that workload. Being a pod or being a deployment, we still want to be able to support that as much as possible. The reason I say as much as possible is also different from in the cloud, where we have almost indefinite amount of resource. If a machine goes down, we can get a new one. On the edge, there's usually very limited amount of resource. So there's a case where if the third condition happened, we don't have any more resources, still we cannot support it. But if we have enough resource, we can shift around the workload to other nodes that's available. So we want to support that scenario. That's why I said as much as possible. Okay, so this is the first kind of requirement that we want to support is autonomous. We want the workload to be up and running, whether condition 1, condition 2, or condition 3, which is a combination of 1 and 2 happen. Okay. The second one, we call that the flexibility. We could probably use another word, but the flexibility is how we think of this. So the idea is we want to separate the action being the workload running, or the kind of workload, from the control, which could be another set of workload. But the idea is there's a local, there's global, and some action will be run on your local machine, on your local cluster. Some of the workload would act as the controllers and kind of thing, and it will run at a higher level place where it will take the input from all this local input and it will do something there. So two possibilities. One is we want to be able to support both local and global. For some cases, we prefer the local because for them, we want super fast latency, super small latency. And we want the data locality, meaning that some user, they prefer to not send all data into the cloud, or they have their privacy concern. So if this kind of thing happen, we still want them to be able to run their workload, right? And also in other case that the user might say, I don't want to send all my data to the cloud, but I can send in some of the data and you can do some analyze based on it, and then send back to improve whatever is running on my local machine, on my car, on my cell phone, or on my camera, right? So we cannot say which one should be the case for the edge. It's really the choice by the user. And in our design, we want to support these cases. What we want to give the flexibility, give the choice back to the user. So we want to support as much cases as possible. Whether you prefer the local one or the global one is your choice. Okay, based on the requirements, we think, okay, it's not just one cloud, one edge. It should be some kind of data center in between. So it could look like this. We have all the devices. Devices would connect to some machine. Here I said the data center, it could be just a small machine. It could be just a very big cluster. So it's not just a huge data center like Amazon, all those AWS things. But it's still just one device. All the devices would connect to the data centers. And the data center would connect to the cloud. This is the original image that we have in our mind. But after doing some research and based on the picture we saw earlier, actually, it's not just one more level, right? It could be a few more levels. So that's why we said, let's just extend this to allow this flexibility come in, meaning that if the user has more levels of data centers, has more level of size, we still want to be able to support that, right? So essentially the first kind is IoT Edge. We said, okay, for IoT Edge, actually it's not new. There's a bunch of solutions that are already there. For example, Kuba Edge is very good at supporting this. So, but for the first kind, it can support, remember that condition 1, 2, and 3. It can support only one of them. For example, if the connection goes away, the workload is still run. But if the workload and the connection goes away at the same time, then there's nothing you can do for that. So the way to solve that, apparently, the reason that the Kuba Edge or the IoT Edge cannot do that is there's no control plan, right? The control plan needs to be involved if we need to reschedule anything. So let's put a control plan on the edge. This is where the edge cluster comes in, right? Instead of just having one node on the edge, we can have control plan on the edge, and we have a cluster, and all this node will be in the same region or same field, very close to the control plane. So the control plane can still work. And if you get rid of the connection and get rid of one node or two nodes, because we have a control plane there, we can still shift around. So for this case, the design is okay. So if we have edge cluster support, we're able to support that autonomous idea. So remember, we have two. One is autonomous, the other one is flexible, right? Autonomous, if we put a cluster here, that should work, right? Then the other one is flexible, right? If we just have this, we said it's not just 3 layers. Here we have actually 3 layers, the cloud, the data center, and some device. Imagine if you have a camera and imagine this as a work node, right? The device will connect to this. This is essentially that the data center that we talk about. So the device will connect to the data center will connect to the cloud. This is like 3 layers. And we said earlier that while this is good, this can support autonomous, but it's not flexible enough, right? So the idea here is in our design, we want to extend that further. We want to say that if you have another cluster or a few clusters, based on your requirement, based on your topology, if you want to connect them together instead of connect everything to the cloud, we still want to be able to support that. And the scenario for this is the user say, I have all my data here. I don't want to send that to the cloud. I want to do some processing, but I could have a bunch of these clusters around here, and they can send in some information to a higher level. For example, in the Seattle, you can do some processing, and the whole Pacific Northwest could have its own data center. It could do some aggregation of all the data sent in from all the Pacific Northwest cities clusters, and you can do that. So if the user decided that they have this kind of topology, we still want to be able to support that. And the way to support that is we want to provide this kind of capability so that a cluster can be connect together in this way. We call this a hierarchy or cascading edge cluster. You can have a bunch of those. It's not, so again, here, the person or the entity, the side that decide we want this kind of connection or we want this kind of topology is not us. We just provide the capability, and if the user wants to do that, they can, right? It's not us that's making the decision. And then you may have this question based on the cascading cluster here, that do we want to connect? For different kind of scenario, you may want to do different things, right? There may be cases where I have all this cluster. I don't need that kind of hierarchy cluster. Also, for some reason, I cannot connect, for example, some edge cluster on the edge, they do not expose anything out. So if that happens, here all the other local cluster, they cannot connect to it, right? For this case, the user may say, it's fine for me to connect everything to the cloud, to the central cloud. I still want to control everything to the central cloud, from the central cloud. We want to support that. Actually, that's the first step we want to support it in our proof of concept, that we are able to control and send the deployment, send the pod to the remote edge cluster and be able to see it, be able to see the status, all that. So that's the first kind of scenario, and we want to support this. The second one, of course, is the case where we have a set of clusters, they can be connected to together. The user, they can say they are able to control that, all of that from the cloud. And maybe they say, if something goes wrong, if the connection is down, I still want to be able to come to the cluster, for example, come to my machine room. I want to access that, right? Otherwise, I don't have any visibility there. So the user, in our design, we still want to provide this kind of thing. So that would be the second model. And again, the choice is in the user side. There's it's not on the left or on the right. They have different scenario. For edge, it's a very complicated thing where people have different situations, so we cannot make any assumption here. But the first kind is very good for the cluster on the internet. You have a bunch of cluster, you want to control it. The second one is we have some kind of hierarchy, and we have different kind of processing on each cluster. It's not the same one, just distributed. It has its hierarchy topology. If that's the case, the user can still choose to do it like this. Okay, then following this, you may also have the question, okay, we have this cluster, how do they even connect to the cluster in the cloud? Where do all this cluster come from?
I'm sorry. Can I ask you a question about this control here? If I'm understanding this correctly, would this be like configuring, I mean, just a very technical terms, configuring my cube CTL to connect to this particular cluster, let's say C11 or C1? Or are you talking about different controls, like, you know, connecting with UART or some USB or whatever? To the machine and then managing the machine?
The control here is referring to the first kind.
Okay, thank you. Okay, I get it.
The best case is the user can sit in one place, right? They call that a single pane of glass, a single pane of glass, where you see everything and you say, okay, I see this cluster C11. I want to see what's running on it, what's the health condition, and if I can deploy something. So this is the kind of control. It doesn't have to go through control, but yeah, that's the kind of control we're talking about.
Yeah, the reason why I asked this is because then managing all the configurations and managing the cluster control planes can actually theoretically get quite challenging, because it can be a very large scale.
Right. Yes, that's a very good question. The idea we have so far is, if, for example, on the right, if we have too many of this kind of cluster, whether they're connected to the central or whether they're connected to each other, if we just report everything all the way up, it's going to get more and more congested, as you may imagine, right? The idea is on the higher level, everything is just looking down, meaning that everything is just taking control of what's right beneath it. And if we want, we can dive down into, for example, if you are here, if you want to see the conditions here, by default, you will not see the details. If you do want to see that details, we have a way to send in those requests, essentially just asking the C11, hey, tell me more about your situation, and that can be reported. So we'll just combine two different kind of status reporting ways.
Hey, Peng, what do you mean details? Previously I thought I understood this, but maybe I missed something.
For example, if you are at a higher level, you just see this C11 cluster running. What kind of workload is running on it? What's the condition of those workload? For example, we have a deployment running on C11. The user by default, he will just see that, okay, I have all my deployment, they go to different cluster. And if they want to see a certain pod running in that deployment, then for that case, we probably have to like send in a request, and the request will be passed through to here to be reported. By definition, by default, we don't report every single pod status all the way to the higher level, the highest level. Otherwise, it could get there could be a scalability.
Yeah. If I only connect to the top level of the cloud data center, as a user, can I still see the pod level information?
You mean the one on the left, right?
No. Let's say if I only connect to the blue one, I know you internally you might send some request to the down level to retrieve the information, but from user perspective, this is transparent. Does the user still able to see the pod level information if he only connects to the top level?
I think the answer is yes. So the user should not be aware. It's like you think of that the folder with a expanding feature, right? You see a file name, you click that, and it will expand and show you more.
I see. Yeah. So yes, that's what I want to confirm. Yeah. So users still able to access all the information, even because I don't want to say you have to physically connect to that cluster if you want to.
Right. No.
That will be kind of weird.
Yeah, that phone call is going to take a very long time. But yeah, think of this as we use the anatomy like in the army. The top level, they can still get the status of every single soldier, but normally they just talk to their lower level or their direct contact. And if they want more information, that information will come from the bottom.
Okay, thank you.
Okay. Back to the question: if we say, okay, we want to support both, where do this cluster come from, right? How do they connect to the central cloud? What's the process? There are different ways. One way, actually, I should put this slide the other way around. One way is I'll do this one first. If you have a cluster already and it's running in your data center, in your house, in your in like a university, you can run some of our components. That component job is to set this control plan on the edge so that it will talk to the cloud, it will do the reporting, it will do the connection. And by having this connection, then the user can see the status of this cluster from the above. So that's the first kind. We call that attachment. Essentially, you have a cluster, you connect that to the existing cloud, and then now you're part of this bigger cluster, right? The other kind is actually we have we're still working on this. The idea is from the user's perspective, if they want to have a cluster on the cloud and they have some node, we want to provide a feature where the user can say, I have five nodes here, and I want to run a deployment there, and I need a control plan there. For this case, I don't want to care who is the master, who is the work nodes. I don't want to care about that. So we want to provide a feature that the user, while still connecting to the central cloud, they can just select a bunch of nodes and say, put this together into a cluster and send back the information to me. We call this self-organizing. So the user doesn't have to worry about all those things. They will connect to each other. Being able to do that apparently is not going to be straightforward. We need to put some software on it, and they should be able to switch from a different role for being a edge node or edge cluster master or edge cluster work node. So we're still working on this idea. So far, two options. One, you can just have one cluster, you can connect it to the clouds. The second is you can have this kind of self-organizing system. Okay. All right. This is just a bigger picture. Actually, there's another thing that we're still working on is we call that east-west connection, the inter-edge communication. This is very important for like MEC, the third scenario where the user can move around, right? Then so far, a lot of the communication, for example, if you have one session or if you have some application running here and you have some application running in Seattle, the other one run in Salt Lake City, then the connection has to go through the central cloud and all the way down to Seattle. So as you can see, that's caused a lot of latency increase, which could be very large. So the idea is we want to establish this kind of connection between this so that if the user want to quickly shift from this one location to another location, all his session data, all his things stored in this cluster can be sent over, can be communicated over to the other cluster, and the user can still enjoy the same kind of latency. He doesn't even have to know this, right? And the idea is we don't have to go through the central cloud. This is another part of the proposal that we're working on. Okay. Okay, so far that's the higher level introduction and ideas that, as you can see, we have a lot of ideas. We're still working on some of this to get more details to see where we can improve, and we will have some feature design. So here is the schedule. We started in March. We have a bunch of reviews. We're doing the proof of concept. And it's we got some progress, and it's very promising. So we're happy with that. And at the same time, when we do the POC, the feature design, the actual official design will be based on what we find in the POC. And in the POC, it also exposed a lot of work for us to do. So something simple in idea, but it may take time to actually get down to work. So we found a lot of this, and we implement a lot of ideas that, okay, we can see that it can be implemented and how much work it takes. So the POC is going fine. We are here today, apparently. Here is the overall plan. So we will have a final or the official design by end of May, and the first release will be by the end of July.
Hey, Pengtu.
Yeah.
Could you go back to the China Unicom slide where you were like far site and cell sites were presented?
Yeah.
I mean, are we looking into Starlink X at all in terms of like how they are referring to the design? Could you briefly talk about this slide? Are we the one who are presenting this, or like is it a slide from someone else?
This is a slide from someone else. These are the reference. Yeah, we're not basically here is what we want to see what the future data center look like, and what other people are thinking of, or what other people are trying to solve it.
Got it. Do we have any reference point from China Unicom's or like any connection? Because I would like to understand a little bit more their challenges with the like 50 millisecond sort of like latency versus 20 millisecond latency.
We have connections with in the Cube Edge MEC. I think it's the Cube Edge MEC SIG.
The Kevin guy, right?
I think in that.
No, Prashant. So yeah, so we collaborating with China Unicom, China Mobile as well. As part of we building blueprint as part of Acrino actually.
Got it.
So this whole MEC thing, the multi-access edge cloud. So just to give you a reference, so there's a lot of information. All of the work the China Unicom folks are doing as part of GSMA actually. And there are a lot of 3 or 4 white papers. I can send you the link. They're publicly available. Sure. And they capture a lot of details, a lot of gory details. So I'll send you the.
And what's the correlation with the Starlink X? Because in the next slide, you talked about Starlink X after this, Pengdu. Was it a previous slide? Yeah, there you go.
Yeah, well, here you can think of this just as like a literature review.
Literature, okay. I mean, because these are like important projects that are going on currently. Starling X is a very important project. So I would like to understand that how we are referring to those. But your presentation was very thorough and very helpful in terms of like the design aspect of it. And like to hear more in the next meeting if possible.
Sure. Sounds good. Yeah. Yeah, we want to find a place where I think everybody is their field that everybody is working on.
Mm-hmm.
We want to find some other field that we think is if we look forward from what we have today, those are the features, and those are the features. For example, the hierarchical design and the inter-edge connection communication. Those are that we think that okay, from our understanding, we think those are important, and we want to build that for the customer.
Got it. Deepak, would we also look at the Starling X? Is it an open source or it's like a closed source? I think Starling X is an open source project.
I'm not that aware of that. Where did you get it from, Peng? This.
There's a talk here.
Okay. No, I'm not aware of that. So what is that? Is that like MEC cloud? What exactly does it do? Starling X.
Yeah, go ahead.
Yeah, you can see from the picture, it's trying to do things. From what I remember, they build on top of, so they build their own binary and run that on the work node to support all this control. They want to, it's like compute network.
So it's a hierarchical thing. So they build the hierarchical structure on top of Wind River, looks like Wind River and all that kind of stuff.
Yeah.
Yeah, Wind River is what I see the name now. Okay.
Yeah, for this part, I think if we're interested, I can send some information after the meeting.
So the GSMA document, which I think I'm pretty sure it will talk about this as well, because they pretty much capture all the work going on in the community. I mean, in pretty much across the world, and they covered all the projects, including CubeEdge and all. I think they have Ajax and a bunch of other projects. So they capture, they kind of cover the landscape, and they kind of describe what exactly are the requirements from a GSMA, the 5G standpoint, from a platform standpoint. All those 3 white papers, I'll send you a link.
I think the Starling X project, some of our colleagues should be connected because it's part of Open Infrastructure Summit. It was announced in that. And it's more related to the infra in the edge computing. So I believe like if we have, we talk to some of the people like Fred Lee and other people back in China, they are already involved into some of the open source contribution to the Starling X related area. I'll also send him a message and check what is going on, because it looks like they're practically doing a similar, like deploying an edge cloud, creating an edge cloud. And when I look their architecture and design, it's a starlingx.io. I'll paste the link into the communication so that you guys can also refer to that.
I appreciate. But do you know who is a major player in the Starlink? Which company?
No, maybe.
I think MTN is a major player. Then some of the companies like Deutsche Telekom is also there. Starlingx.io.
Starlink X, you miss X, I think.
Yes. I don't know whether I can paste it somewhere. I wanted to message. I don't know.
Starlinkx.io. Starlink.
Yeah, open. So this one, the first one.
Yeah.
If you look at like the design, it's pretty much more like in line with what we are doing, or maybe in line with the Akrino and whatever the Anuket and all those things are there. So you can see the open stack. Yeah.
It looks like a complete infrastructure stack.
Yeah.
Right?
Yeah, people from China are, I'm 100% sure that Fred Lee and others are connected into Liang Li, his name is. These guys are already part of like Open Infra Summit.
Yeah.
Okay, yeah, thank you for this information.
Yeah, the moment I saw in Pengdu's presentation, I was like, okay, where did he get all the Starling X related stuff? So.
Yeah, the information, the picture, I put all the reference here. So
got it.
yeah.
Got it. Okay.
I think we're almost done. So I'll just go through the rest of the slide and we can answer question after that. As I said, we're doing the proof of concept is going through, and the kind of solution we referenced. One is for the IoT edge. There are 3 of that. There's more, but the open source world, we checked out the Cube Edge and OpenUART mainly to see the difference, to compare and see why they're doing what they're doing. And this one is from Baidu, also from China. This is from the IoT edge. The proof of concept that we're doing is based on Cube Edge. It's not to say that we are working on Cube Edge. It's just that we're using whatever Cube Edge provides to extend and to prove that to prove our design. Okay. For the other side, so the first one is one edge node. We call that IoT edge. The second one is federation and the cluster registry V1, V2, and there's a new guy from it's called Karmada. It's also, from my understanding, this is another version of federation. And also there's other solutions in the Cube Edge community that they're also working on, like edge cluster. So we are also keep an eye on those solutions and how they're going and how they compare to our solutions. Yeah, here is the feature list that we want to experiment, that we want to put into design. I will not go into the details. These are the things that we think that could be valuable for our POC and for our final design. And the idea is 2 streams. One is coming down, right? If you have a workload, you want to deploy that from the central cloud. How does this workload come down to a certain cluster based on what the condition and how we connect, right? To answer all those questions. The second one is to the upstream. We have the status. How do we report those stats? What do we report? And based on this 2 direction, we have all this list, and we are doing POC on some of this. And I think that's it.
Okay, thank you, Peng, for the sharing the information from EdgeSig. It's very informative. Any more questions about this part?
Nope, I think that's great.
Deepak, Stefan, do you guys have any more questions?
Yeah, I think one comment. Oh, yeah, go ahead, Stefan. Yeah, go ahead.
I also have nothing really tangible to say. I was just going to say thank you, and definitely interesting to look into this a little bit further as the things develop, and would like to stay in the loop.
I think just before we wrap up, I just wanted to. I think we've been exchanging, especially Prashant and Drupal, the email thread I started about possible reference architecture for telecom. I think one opportunity. So there was a lot of good information exchange. So you think, Prashant, you think that somebody from telecom ecosystem would be interested in that and participating in this discussion and kind of formalize maybe the reference architecture, from telecom side, and similarly, I think we would want to explore other vertical segments as well, maybe financial services and all that.
Well, we have been working on some of the areas, and in this current release, we are focusing on making sure that Centaurus as a piece is deployable and stable in nature. In the next meeting, maybe I can show you guys some of the stuff that we are doing on the industry specific area, where we have put together like a lot of different accelerators and POCs with partnership with Microsoft. I can give you a preview. I don't know whether I can share my screen or not. Let me see. Yes, I can. Okay. So do you see my screen here?
Yeah, we see it.
So we have built like in partnership with Microsoft several industry specific solutions. They are not edge specific, but if you see like if we go and talk about like demo site for manufacturing. So this is like capturing all the manufacturing data and having dashboards for manufacturing like campaigns and real-time analytics coming from IoT devices. These are like race car and then different IoT devices producing the data. These are mostly like a sample application. And again, you can see other solutions like energy, healthcare. We can go to healthcare and pretty much again, the similar kind of work that we are doing there. And we are working on packaging these for the end customers so that people can consume this as a solution on their cloud related solutions. So these are like edge care, healthcare, financial analytics, and all those things. Ultimately, at some point of time, all these solutions like what I'm looking at would be an industry specific solution and fit for the edge computing scenario. So I'm sort of thinking myself like how to get this thing together in terms of here is the financial sector, and these are some of the example, and most of my team members are very familiar with that because they are involved in development of these scenarios. So we'll walk to the path when we have certain things ready in place. So I'm waiting for like first version of Centaurus and then seeing that how these solutions can run on top of it.
Good, good. I mean, the email thread was just to kind of start the conversation. So
No,
see if you can.
That's great. That's
very high level, more like a position paper kind of thing.
Yeah.
And then obviously it's going to take time for us to build out. A lot of functionality needs to be built out.
Yeah, but industry specific solutions are there. We are already looking into it. I think we are slightly ahead into the process with that, which gives us a good visibility that what we can bring onto the table. So Dr. Shang also, I discussed that and I told him like, let's get the first version out. And we both are agreement that, yeah, we should just finish the first Centaurus related basic and test the environment. Then we start looking to the edge computing with CubeEdge, and that's why I talked about the Starlink X project today. And then see the industry-specific solution integrated on top of it, so that we see the traction from appropriate customers.
Perfect. Good.
Yes, Prashant, that's correct. The edge part that the 2 is present, and that's part of that. We can talk about later on the SAW side.
Yeah. So we are looking into all those things, solutions, and we are trying to bring this together also. So those are the progress happening. I'm very happy that we saw Pengdu's presentation today because that has triggered some good communication. Pengdu, if you can share that information with us, I will write my own comments on certain areas and share it back to you.
That's good. Thank you. Will do.
Yeah, we will send the link out. Everything shared in the TSC meeting will be public. Yeah.
Perfect. All right, Deepak will continue to that email thread and we will try to get to some point. Yeah.
Good, good.
Okay.
Thank you, guys.
Thank you, guys.
Thanks all.
Thank you.
Bye-bye.
Bye.
Bye.